Hello. Thank you for your interest in our project entitled SHARK, or Student-Focused Holistic Aquatic Robotics Kit. SHARK is a bio-inspired STEM education toolkit that uses biology to teach students about relevant naval engineering concepts. It consists of the parts and instructions necessary to build 3 age-appropriate bio-inspired robots and has lesson plans that use the robots to teach concepts like speed, frequency, buoyancy, waterproofing, electronics, and other concepts related to naval engineering. This work has been funded by a Phase 2 STTR from the Office of Naval Research. I would also like to acknowledge our academic partners, the University of Delaware. Before I talk about SHARK, I'd like to give a quick overview of Spectral Energies. The company was started in Dayton, Ohio in 2006 as a laser-based combustion and flow diagnostic company. In the nearly 20-year history of Spectral Energies, we have grown to have about 35 direct employees and 35 associates that work closely with the company. We have expanded from our roots as a diagnostic company into many different areas. Some of the key areas we are heavily focusing on include developing hypersonic technology, developing next-generation directed energy solutions, developing alternative position, navigation and timing, developing advanced propulsion concepts, like rotation detonation engines, developing and selling custom lasers, and other R&D projects. Our expertise in fluid dynamics, electronics, product development, and a strong passion for STEM education has led us to developing SHARK. SHARK is being developed with funding from the Navy STTR topic N22A-T023, titled Aquatic Soft Robotic STEM Education Kit. The objective of this project is to develop next-generation STEM education aquatic robotics kits that teach students about naval engineering concepts and inspire them to pursue careers in STEM. We expect that this project will result in a product that can be transitioned to K-12 educational facilities and at-home learning. This will impact the Navy's area of interest in ground-sea vehicles and materials processes by training the next-generation workforce that will work in these areas. Developing the next-generation workforce is critical to maintaining the United States' technological advantage over its adversary. The country needs well-trained individuals that can work on emerging technology, like uncrewed underwater vehicles that can perform and enable a diverse range of underwater missions. Understanding the math, science, and engineering that goes into these vehicles will be crucial. The Navy is already focusing on training the next generation with programs like Sea Perch and Sea Jelly. SHARK is continuing this strong tradition of STEM education and builds on the success of these programs and provides increased creativity and learning opportunities. SHARK provides customizable builds that allow students to create their favorite underwater creature, real or imaginary, and test various design parameters. SHARK uses this bio-inspired/biomimicry flair to inspire students interested in biology, oceans, fish, etc., who are traditionally uninterested in robotics. SHARK is not just about building fun robots and watching them swim. It is also about education. Educational material is being developed that will use the robots to teach students about STEM and naval engineering concepts. So, what is SHARK? As I mentioned earlier, SHARK is a bio-inspired STEM education kit designed to excite students about STEM and teach relevant naval engineering concepts. The kit has 3 age-appropriate guided robot builds. The simplest design, used for elementary students, is called the Wigglefish, previously the Twiddlefish. The design uses a flapping tail-type propulsion system. Students have the opportunity to customize the design of the fish by molding the body out of silicone putty and creating a tail. This provides the student with the opportunity to test the effect of tail size and shape. The middle school build, the Octobot, is inspired by the octopus and squid. It has tentacles that open and close. When in the water, this causes the Octobot to swim. Like the Wigglefish, students have the opportunity to customize the head and tentacle design. Unlike the Wigglefish, Octobot has controls to adjust the heading and pitch. The final build for high school features much more complicated design features. The flippers used to propel itself in the water require complex mechanical motions and multiple servo motors. The robot is equipped with sensors and actuators that allow students to develop controls for the robot. Shark is not just about building fun robots and playing with them. The kits will include lesson plans that teach core concepts about design and naval engineering, with the end goal of training the next generation of technicians, engineers, and scientists that will design future underwater vehicles. In addition to the kits, Spectral Energies envisions an annual design competition. Mission requirements for the competition will restrict students to use parts included in the kit and focus on biomimicry. Currently, we have designed and tested the elementary and middle school builds. The high school kit is being designed and optimized. We are now focusing on finalizing the kits and developing the educational materials. Shark offers many features such as bioinspiration, underwater robotics, customizable, and affordability. For example, Shark uses bio-inspired designs to excite a wide range of students, including those traditionally not interested in robotics. This will inspire more students to join the STEM workforce and improve diversity. Shark is also customizable. Shark is designed to have extreme customization and bring out the students' creativity to make learning fun. For example, students can customize the type of fish they want to make in the Twiddlefish kit. Examples include the clownfish, shark, northern pike, and even mermaids. Shark was carefully designed with cost in mind to ensure it is affordable. The total kit costs about $200 and individual builds can cost between $20 and $40. SE's plan to transition this technology to the fleet is to incorporate Shark into school curriculum so students can learn about naval engineering concepts. The hope is that some of the students' learning concepts will work for the Navy or its contractors to design, build, and operate UUVs and help the fleet complete its future missions. We are currently working to find schools willing to do a pilot program, and we are seeking help to fund kit development and integration into different classrooms. SE's product will fit into the private and public school markets. It will also fit in with after-school clubs and the STEM education toy market. SE's business model revolves around building and selling Shark. We plan to work with both industry and government officials to fund schools to purchase the kits and integrate them into the classroom. Partnering organizations would be allowed to put their logos on the kits, include their information on the website for our product, and include information at a design competition. In addition to integrating the kits into schools, SE plans to sell the kits to individuals interested in at-home learning. Thank you for your attention. If you are interested in learning more about Shark or Spectral Energies, please reach out to Dr. Sivaram Gogineni or Dr. Christopher Rusher. Their contact information is listed on this slide.